Ancient astronomers from almost every culture knew of 7 things in the sky that moved. 6 of them were the Sun, the Moon, Mercury, Venus, Mars, and Jupiter. The 7th and slowest of the moving things was the one named after the Roman god of time, Saturn. For centuries, Saturn was just a dot in the sky. Then when telescopes were invented, our perception of the planet changed dramatically. Learn more about Saturn and what makes it different from every other planet in the solar system on this episode of Everything Everywhere Daily. This episode is sponsored by Kachava. Hey everyone, I wanted to tell you about Kachava, my all-in-one daily super blend. If you're worried that you aren't getting all the nutrients you need or struggling to stay on top of your health, then listen up because Kachava has you covered. Kachava puts everything in your body in one glass, so you can have it all. All the superfoods, all the vitamins, all the omegas, all the adaptogens, all the greens, all the protein, all the benefits. For your gut, your skin, your hair, your brain, your muscles, your heart, everything. No more compromise, no more guilt, and no other nutrition shake does all of this. They traveled to the ends of the earth to source everything and then crushed it up. Kachava is a powder. You take 2 scoops of it and just add water and blend it up, and it tastes incredible. They have 5 delicious flavors: vanilla, coconut acai, chai, matcha, and my favorite, chocolate. I can drink 1 glass of Kachava a day, and it'll keep me full for hours. Trying to manage all the supplements and ingredients you should be taking can be overwhelming and expensive. But now, Kachava makes clean, organic, superfood nutrition accessible to everyone. So, you gotta try Kachava for yourself. Kachava is offering 10% off for a limited time. Go to kachava.com/everywhere, spelled Kachava, and get 10% off your first order. That's kachava.com/everywhere. The names of the planets that we use in English came from the Romans. There was a sort of logic to how the names were given out. The planet that moved the most was named after the winged messenger god Mercury. The planet that showed up at dusk and dawn was named after the goddess of beauty, Venus. The reddish point of light was named after the god of war, Mars. And the slowest moving point of light was named after the Roman god of time, Saturn. The ancients couldn't have known, but it turned out the reason why Saturn moved so slowly is because it was the furthest away. Saturn lies about 1.4 billion kilometers on average away from the Sun. And to put that into perspective, that's a little under twice as far as Jupiter is from the Sun, and about 10 times the distance that the Earth is from the Sun. In terms of size, Saturn is the second largest planet in the solar system. Jupiter is around 143,000 kilometers in diameter, and Saturn is about 120,000 kilometers in diameter. Yeah, Saturn is pretty big, but that isn't the defining characteristic of the planet. The thing about Saturn, which is really different, is its density. To put it into perspective, Saturn has 764 times the volume of Earth, but only 95 times the mass of Earth. That means its density is only about 12% that of Earth. Or to put it in a way which might be more visceral, assuming this could be done, Saturn could float on water. The reason why Saturn has such a low density is that most of its atmosphere consists of hydrogen and helium, the 2 lightest elements. It's believed to have a solid core which is quite dense, but overall the light elements in the atmosphere reduce its overall density. It takes Saturn 29.5 years to travel around the Sun, but it only takes 10.5 hours for the planet to rotate on its axis. Our understanding of Saturn changed dramatically with the invention of the telescope. Galileo was the first person who looked at Saturn with a telescope, but his telescope wasn't good enough to resolve its primary feature, its rings. Galileo just saw 2 blobs on either side and figured that they were moons, but they weren't like the moons that he saw around Jupiter. The first person to see the rings and who had a telescope big enough to discern them was the Dutch astronomer Cassini-Huygens. He also made the discovery of Saturn's largest moon, Titan. And more on Titan in a bit. As telescopes improved, other moons were discovered, including Iapetus, Rhea, Tethys, Dione, Mimas, Enceladus, and finally Phoebe in 1899. These are just the major moons that were discovered by astronomers on Earth. There have been a total of 83 moons of Saturn which have been discovered in total. The other major discovery before the 20th century was the fact that Saturn's rings were in fact multiple rings with gaps in between them. The various rings were named by letter, but they were named in the order that they were discovered by the gaps between them, and as a result, the sequence of the rings makes very little sense. Going outward from the innermost ring, the order is DCBAFGE, with minor rings and gaps getting unique names between them. The big advance in our understanding of Saturn came with sending probes to the planet. The first probe sent to Saturn was Pioneer 11. Launched in 1977, it passed within 21,000 kilometers of the top of the atmosphere on September 1, 1979. The images it captured were the best ever taken, but they weren't great. Thankfully, it wasn't long before the next probes arrived. A little more than a year later, Voyager 1 flew by the planet on November 12, 1980, and then Voyager 2 flew by on August 26, 1981. The images captured by these probes dramatically increased our understanding of Saturn, its moons, and its rings. In addition to the images they sent back, they were also able to take measurements on the planet's temperature and its magnetic field. These 3 probes were limited in the amount of information they could gather because they were only flybys. They were only a few days where they could take images and collect data. What was needed was a probe that could actually orbit around Saturn for an extended period of time. And that is exactly what NASA did with the Cassini-Huygens mission. The Cassini-Huygens mission had 2 parts. The first was the Cassini orbiter, which was to orbit Saturn to get detailed images of the planet and its moons. The second part was the Huygens probe, which was sent into the atmosphere of Titan and landed on the surface. And here I probably need to talk about Titan, which, quite frankly, is one of the most interesting parts of Saturn and the entire solar system. Titan is the largest moon of Saturn and the second largest moon in the solar system, after Jupiter's moon Ganymede. Titan also happens to be the only other place in the solar system that has an atmospheric pressure comparable to Earth. In theory, if you were to walk on the surface of Titan, you would need a spacesuit, but you wouldn't need the suit to be pressurized. Titan is also the only other place in the solar system which is known to have stable liquids on its surface. Now, before you get excited and think that this is just like Earth, it's not. For starters, the temperature on the surface averages negative 179 degrees Celsius or negative 290 degrees Fahrenheit. The liquid that is on the surface is actually liquid methane. And as far as we know, there's a methane cycle on Titan which mirrors the water cycle on Earth. Liquid methane will evaporate into a gas and then precipitate down in the form of liquid methane rain. The Cassini-Huygens mission was launched on October 15, 1997, and spent 7 years traveling to Saturn. It arrived there on June 30, 2004, and put itself into orbit around Saturn by actually flying through a gap between 2 of the rings. On Christmas Day of that year, Huygens and Cassini separated, and Huygens landed on Titan on January 15, 2005. The images returned by the Huygens lander weren't great, and there weren't many. It didn't have a long operational life after it landed. But it did return some images, the very first ever taken on the surface of a moon of another planet. Further radar observations of Titan by the Cassini orbiter found evidence of lakes near the North Pole region. While the Huygens part of the mission didn't last very long, the Cassini part of the mission lasted far longer than originally intended. The original mission was only supposed to last 3 years, but it actually ended up going for over 12. The orbiter was finally destroyed by flying it into the atmosphere of Saturn on September 15, 2017. Over the 12 years it flew around Saturn, there was an enormous amount of data that it collected. One of the things we didn't know much about beforehand was the Hexagon in the North Pole of Saturn. This was originally discovered by Voyager 1, but it was investigated further with Cassini. Scientists aren't sure exactly what causes the hexagon pattern to appear in the clouds, but the best current guess is that it's some sort of standing wave. Researchers were able to replicate a similar pattern doing tests of rotating fluids in a laboratory. The hexagon did change color during the Cassini mission, going from a bluish color to a more golden color. The hexagon shape does not appear on the South Pole. Instead, there appears to be a hurricane-like storm there that has its own eye. It did a flyby of the moon Enceladus, which was only 50 kilometers from the surface, and it actually flew through a geyser plume where it detected water, CO2, and hydrocarbons. In 2012, it was witness to an event known as the Great White Spot. This was a huge storm that appeared in the northern hemisphere of Saturn. It seems to occur on a regular basis about once every 28.5 years. It's similar to the Great Red Spot on Jupiter, except that it's temporary. Another discovery was learning more about Saturn's rings. For starters, the rings are 99.9% water ice, and only a small amount of rocky material. There isn't actually a lot of material in the rings. They're very thin, actually varying from only 10 meters thick to about 1 kilometer thick. The entire mass of ice in the rings is only about half of the mass of all the ice found in Antarctica. The particles which make up the rings are also not very large, ranging in size from a few millimeters to maybe a maximum of about 10 meters. One of the current theories is that the rings of Saturn are only temporary. We just happen to be living at a time where we can observe them. It appears that what's happening is that the ice particles are slowly being pulled into Saturn due to its magnetic field. The amount of ice being lost this way is estimated to fill an Olympic-sized swimming pool about every half hour. That means that the ring may only be about 100 million years old and may have less than 100 million years left. That may sound like a very long time, but in the age of the solar system, it's very little. The source of the ice making up the rings was probably a comet or a moon, which disintegrated at some point. The gaps in the rings primarily come from gravitational resonance with the various moons of Saturn. Because Saturn is so far away, it's a very difficult place to reach. Without the planets being in correct alignment to get a gravitational slingshot, it can take many years. There aren't as many future proposed missions as there are for planets such as Mars, which are much easier to reach. One of the only proposed future missions is NASA's Titan Saturn System mission. Some of the current ideas being floated for this mission might include a balloon that would float in Titan's methane atmosphere, as well as a boat that could sail in one of its methane lakes. The mission hasn't been approved yet, and no funding has been allocated. If and when that does happen, the launch might not occur until sometime around 2030. Saturn is an interesting planet, but the really interesting things to explore will probably be its moons, especially Titan. There's really nothing else in the solar system like Titan. Its relatively thick atmosphere and its liquid surface provides the only opportunity to study such an environment. On a personal level, if you ever get the chance, participate in a star party in your area. It'll usually involve some amateur astronomers who bring their personal telescopes so the public can look through them. I remember participating in one at the Visitor Center on Mauna Kea in Hawaii. If you happen to visit while Saturn is out, you'll clearly be able to see the rings of Saturn with your own eyes, and maybe even Titan. And if you do happen to see Saturn and its rings with your own eyes, you'll be able to say that you saw something that even Galileo didn't. Everything Everywhere Daily is an Airwave Media podcast. The executive producer is Darcy Adams. The associate producers are Thor, Thomsen, and Peter Bennett. I just wanted to extend a big thank you to everyone who is supporting the show over at patreon.com. I have show merchandise available there, including hoodies, t-shirts, and stickers. Plus, it really just helps me get this show out every single day, including, of course, weekends and holidays. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.